Hello, everyone. This is a recorded example for Public Health and Community Health 3313. And in this example, we're going to go through how to import your data into Google Colab and then how to do some summaries of that data once you have it in there. So in a previous video that I posted on YouTube, you should already have an example of how to get an R script running in Google Colab. So if you don't remember how to do that, please go check that video out first. The most important part being that you're going to want to make sure that you're running in R and not in Python. So to get started, the first thing that we want to do is to start a document in R script in Google Colab using this link that I put on the screen. So this colab.to/r, the lowercase r, will automatically open up an R script for you in Google Colab. Note that capital R will throw an error. And there are other ways to do this, but I found that this is the quickest way to get a program running in Google Colab. Otherwise, you're going to start a program that's working in Python that won't run the code that we're going to want to run. So once you've done the colab.to/r, you can go to this runtime option up on the menu, and then you can scroll down to change runtime type, click on that. And you can confirm that right here, this runtime type is set to R. If something else shows up here that asks you just about the hardware accelerator and you don't see that R is the option, then you're running in Python and you need to open this link again to make sure that you are working in R, not Python. Okay, so the first thing that we're going to want to do is we're going to want to import our data into R. Now, the code that we're going to do that with, I'm going to copy and paste into here. So this will import our data and it will read in a CSV file. Now, the names of the file are going to depend based off of your group. So each group has a different health outcome that they're interested in. Well, I have an example data set called NHANES_DM, standing for DM is for diabetes, .csv. That's the file that I'm going to import, so I'm going to want that name to show up right here. But let's see what happens when I run that. So it's going to take some time to initialize and connect to the server. That's what we're seeing now. And then eventually, it will run this code for us. Okay, it's working a little slow today, but it finally ran. Now, notice that we get a warning message whenever we do this that says warning message in file. It cannot open the file. No such file or directory. Okay, so the issue here is that this Google Colab, this R script, is pointing our code or the R to this file folder called content. So it's looking in this folder called content and looking for this file name, but it's not finding it. So we need to make sure that we've uploaded the data to Google Colab so that it can look for and bring in this data. So the way that we're going to do that is we're going to go over to the left-hand side of the screen, and here there's this folder icon that stands for files. So we will click on that. Okay, so this opens up the content folder that's being referenced over here in our code. So what we need to do is upload the data to be in this location so that R can read it in. So then what we're going to do is we're going to go to this button here with a page with the up arrow on it, and this will allow us to upload a file to Google Colab. So we'll go ahead and click on that button. Now, I don't know where this folder is going to automatically send you on your desktop, but you need to be able to locate where you have saved the data onto your computer. So you need to make sure that if it's in your downloads folder, you go to your download folder. If you have a project folder for this project, go there and look for this data. You just need to be able to locate your data. So I said I'm going to work with the NHADES_DM data since this is my example data. I have not assigned diabetes to any of the groups in our class. So I'm going to use this as an example. So I can select that and then choose open. Now we get a warning here, and it may be tempting to quickly hit OK and move on, but I want to explain this warning to you. So here, this warning is saying that ensure your files are saved elsewhere. This runtime's files will be deleted when this runtime is terminated. So what this warning is telling us is that if you close down your browser, I'm working in a Firefox browser, you may be working in Chrome or Safari. If you close down that browser, then R is going to kind of purge your data and it's going to delete that data from this location. So what that means for our project is that every time you close your browser and you come back, you're going to need to re-upload the data before you can get it to work. So that's what this warning is saying, that every time you come to work on this project, double check over here on this left-hand panel that you see your data set in this folder. If not, you're going to get this error that's on the screen. Okay, so let's move back over to our code console. So now that I have this data here and I have this named as NHADES_DM.csv, I'm going to go ahead and hit run and see if that error goes away. Okay, so no error. So that makes me think that, all right, maybe it brought in my data. So what we've done is we've read in a CSV file and it's located in this location. And this is the name of the file. So this is what you'll need to change for your data set. Now we've read it in and we've called it the data set. We've called it sample.data. So if we ever need to refer to our sample or data set, we'll call sample.data. Okay, so let's do some next steps after you've read this in. So I'm going to add a line of code. The next thing that I highly recommend you do for this project is use this function called attach sample.data. So this matches what we named our data, and we're going to use this function called attach. Now, normally you need to be very cautious when you're using attach if you're doing a lot of data cleaning and data manipulation or data wrangling. But since we're just going to do summaries and descriptives and statistical inference, we don't need to worry about that as much. Okay, so then what does attach do? If we run it, you'll notice there's no output. But what this function does is it takes every column in our CSV file and makes it into a variable that R knows how to run. So now we have a variable for each column from our data set. Okay, the next thing that we want to do is maybe we'll want to see how big our data set is. So then we can look at the dimensions of our data, copy and paste in some new code. We can look at the dimensions of our data to confirm how many number of participants we have and how many variables we've ran in with our data. So we do this by using the dim function. Dim is short for dimensions. And then we're referencing our data set. We want to know the dimensions of our data set. So we put sample.data here. Okay, we can go over and click the play button. And it'll give us a 30.5. So what this is telling me is that this CSV file that we ran in has 30 participants and it has 5 variables. Now, mine is just example data that I've generated randomly. So this is not going to match yours very much. You will have 5 variables. However, each of your groups is going to have a different sample size, but this number should be somewhere from 2 to 4,000. So this first number for you all should be 2 to 4,000. This second number should match and should be 5. If you get something different than that, please contact me because you're probably reading in the wrong data. Okay, so we've imported our data. We've created each variable, each column in our data set has now been made a variable in R. And we've looked at the dimension of our data. So for this example data, we have 30 participants and we have 5 variables that we can look at. Now, the next thing we might want to do is go ahead and move into summarizing our data. So then the code will create a new block of code. R has a very helpful function that's built in called summary. So we'll use the summary function to look at the sample data. So this function summarizes every single variable that shows up in our data. And, sometimes it's helpful, sometimes it's not, but I normally use this as just an initial glance of what does my data look like? Okay, so we have summary of sample data. We'll hit the play button to see what pops up. Now, you'll see we have 5 different variables that this summary function has summarized. We have ID, we have age, we have gender, we have hours sleep, and we have diabetes. Now, there's some things that we can point out here. Remember from class, we talked about this ID is just a unique identifier for each participant in our data set. You do not need to summarize the ID variable. These are numbers that are assigned in sequence to participants as they come into the study. You do not need to summarize ID. But we do need to summarize age, gender, hours sleep, and diabetes. Now, in class, we've learned that if we have a continuous variable, such as age, some things that we would want to report are the mean, the standard deviation, the mean, the interquartile range, maybe the min and the max. So those are all helpful summary statistics for a continuous variable. Now, you'll see that this summary function gives us the minimum age. So the youngest person in our data set is 20 years old. And it gives us the maximum. So the oldest person in my data set is 49 years old. This is going to vary for your studies. And then it gives us the median age and the mean age. Now, notice from this that the mean is there, but the standard deviation isn't. So we would need to use our own function to come up with the standard deviation. Okay, another variable type that we might want to summarize is gender. Or a categorical or dichotomous variable. Now, gender for this data set is only reported as male or female, and it says the length is 30. That's how many participants we have, and it's telling us that it's a character variable. So it can either take on the option male or female. However, if you notice, this doesn't summarize the frequencies or the relative frequencies. So this summary function is actually not giving us enough information about gender. So this information is not adequate for your final report. You need to report the frequency and the relative frequency. Okay, and then our main variables of interest are hours of sleep, which is a continuous variable. So we have this information that's given, but it's not enough information. And then diabetes. So this is also a character variable. It could take on either yes, they have diabetes, or no, they don't have diabetes. So we'll need to do additional summaries for those. Okay, so let's do some more descriptive statistics for the variable age. Now, in class, in chapter 4, we looked at different ways to summarize and visualize data. And if we have a continuous variable such as age, one way that we talked about summarizing it is as the mean and as the standard deviation. So remember, the function for the mean or the average is just mean, and the function for standard deviation, SD, short for standard deviation, is just SD. So if we run those, we get the mean is this top number, and the standard deviation is the bottom number. So that's to help you get started with summarizing. But remember that that's not adequate summaries for this continuous variable. You'll need to provide more summaries for age. But that'll get you started. Okay, so the next variable, let's look at how we could summarize gender. So we noticed up in the summary function from R that it didn't give us very helpful information. So we're going to have to go about describing this ourselves. Okay, so the function that we're going to use to help us with the frequencies is called table. So we're going to use the table. This will give us the frequency. However, it's not going to give us the relative frequency. So we're going to need to report frequency and relative frequency whenever we have a dichotomous variable. Okay, well, let's run this and see what happens. So we put table of gender, because that's the variable name is gender. And so then it tells us that for gender, it either takes on two values, either female or male. And then this number here is the summary of how many people fall into that category. So in my example data set, I have 15 who I identified as female and 15 who identify as male. Okay, well, that is how you calculate the frequency, but now let's look at how we would calculate the relative frequency. Okay, so what we're going to do is I'm going to give you the code for this, which we've seen similarly before, but all you will need to change for this code to calculate the relative frequency for gender is change this number to be the number of females you have in your sample, and this number to be the number of males that you have in your sample. And then everything below this, you don't need to change. So we can see here that to calculate the relative frequency of females, so we'll calculate this variable called rel_freq females, relative frequency for females. That is the number of females divided by the total number of males and females. So that would give us the percentage of females. And then we can do the same thing for males. We create this variable called rel.freq.males, and that's relative frequency of males. So that would be the number of males divided by the total number of females and males. So this will give us the percentage, or more accurately, the proportion of males in our study. And we refer to this as the relative frequency. Okay, so we can run that. And now we'll see this top number is relating to the relative frequency of females. So we can see that in this sample, oh, I have an error there. See how this number is 15 because we had 15 females. This number I incorrectly typed in is 16, but that should match this number right here because that's the number of males. So this number should actually be 15, not 16. Okay, let's run that again. And now that makes more sense. So if out of 30 people, I have 15 females, well, that's 50% or 0.5 of the sample. And then if I have 15 out of 30 are males, 15 over 30 is 0.5, so that's half. So then that is how you would calculate the relative frequency for gender. Now, there are two other variables in our data set that you're going to be responsible for summarizing: hours of sleep and diabetes, which in my example is diabetes, but in yours, it'll either be your group's health condition. So it could be coronary heart disease, oral health, general health, gout, and then the other options. So you'll need to summarize that. So you'll need to summarize your group's health condition. Now, what you'll do is you'll need to adapt this code, the descriptive statistics for gender. You'll need to adapt the code to calculate those proportions for diabetes. And then for using continuous variable, you'll need to adapt this code to work for hours slept. So I'm not going to show you how to do those because that's part of your examination and whether or not you can do these coding skills. But you already have the code, you just need to adapt it from what's shown above. So then you'll be responsible for giving descriptive statistics for the variable hours sleep, and then you'll be responsible for calculating the relative frequency for your health condition, which mine is diabetes, but yours will be something else depending on your group. Okay, so in this video, we showed how to start an R script in Google Colab. We looked at how we will upload our data over here on the left-hand side, and then we imported the data. We created a variable for each column, and then we looked at the dimensions of the data, and then we looked at different functions that we can use to summarize our data. Please let me know if you have any questions over this example.